Do you want me to explain some of this? You want to ask
Sure.
questions? Yeah. So this is our old forge. So when you're talking about a blacksmith forge, that's what we're talking about right here. So we got the coals lit inside. I'm gonna step right across here. We got the coal lit inside, and that's the heart of the blacksmith shop. What you need to get to your coal is you need to get air into your coal in order to get the temperature up to a couple thousand degrees. That is accomplished by this device here, patented in 1857. Became real popular in the 1860s. So this is a fan. As I crank this is a fan that blows air through this pipe and to the bottom of a forge pot right there. So you put those two elements together, the lit coal plus the air, gets you a couple thousand degrees. So you can see those flames. Those are non-smoky, non-campfire flames. They're more like light blues and greens. That's because the coal has processed itself into coke as it's been burning all day. So those are like flames that are coming out of the end of a torch. So those are very hot. Prior to 1860s, gold rush era, they would have used this bellows up here. So that's a couple thousand-year-old technology. And there would have been a pipe coming from here all the way down to the bottom of the forge pot. And the blacksmith in that era would have cranked on this, and that's how we would have got air to his fire. So that's the heart of the blacksmith shop. Of course, these old-time anvils, we got several of them here. If you look at this vise is kind of interesting. So this is just a post that's buried in the ground, but you notice this vise has a chain. So the purpose of that chain is so when you crank this vise in and out, all the jaws go in, out evenly, and they come in evenly instead of pinching like this. So you get a much tighter grip on your equipment.
I always wondered, even today, I probably could be so shit, but when like they melt the precious metals and stuff like that, how do they keep the pot that they actually melt the metals in from melting?
So I'm just going to take an educated guess. So it's either very, very thick cast iron type metal or some type of ceramic. So the ceramic can take that without melting.
Okay.
So this forge isn't actually hot enough to be able to melt steel. I mean, it doesn't melt it into liquid form.
Just enough
I could put a piece of steel in there, I can burn it up and just make it into a big glob of useless nothing, but I can't turn it into liquid.
Okay.
So that requires a much higher forced air heating type process. This is another forge. If you look at this one here, this is a portable one. Usually there's another blacksmith working on this one. So we built these as an example so you can see. If I crank it out here, roll it so you can see it. So this one that you just looked at, you can't see because of the bricks. But what's going on down here is the same thing that's going on behind those bricks. So you can see our forge pot, and it's nothing more than a small little pot, maybe 7 or 8 inches wide, 7 or 8, maybe 10 inches wide, 8 inches long, and so that's it. That's all we need to forge. So this is the crank, so you can see where this is cranked, and the air comes through this pipe. The air comes to the bottom of this, and then up to the bottom of the pot. So that's the heart of the blacksmith shop. So we made a bunch of these one year, so we would have portable forges to move them for demonstrations and stuff. We were doing demonstrations. So usually this is used all the time. Usually have a partner working here today. That's not here today, but he'll forge and make stuff there, and I'll make stuff at this other one, or we'll switch back and forth. So also another interesting thing, if you're looking at interesting old type equipment, check this old vise out. So if you notice this vise, it's not only mounted to the table, but it's also got a big heavy post that goes down and anchors into the ground and anchors into the leg of the table. So longer, stronger, tougher, rougher. We hammer on this, beat on this, twist on this every day of the week. And it's been here for I don't know how long. But some of these are very, very, very old pieces of equipment.
During the day, what do you actually would make, like horseshoes or something like that, just for demonstration? Or
well, in this shop, we do, a third of what we do is usually items that we sell at the mercantile store. So they give us a list of 20 items, and they say, hey, they'll give us a list, we need these, we need these. So we do candle holders, horseshoe hearts, hoof picks, cording candles, just all kinds of stuff that we keep the store supplied in. Another part of our day is stuff that we're interested in making ourselves as blacksmiths. So whatever projects you're interested in or whatever medium of iron stuff you make, you can make. So I've made hammers. All these tongs along here, these were all handmade by blacksmiths in the shop. At one time when they needed a pair of tongs to make a certain project, they just made the tongs in order that they could make the project. So that's very common. This is an old hammer, if I can find it. This is an old hammer that I made out of a old blacksmithing hammer out of a forklift time. So it was a scrap piece of forklift, and did that. All the chain in the shop is all hand forged and handmade. Another interesting piece of equipment is this right here. So this is an old school drill. And if you had a good, well-equipped blacksmith shop, you'd very likely have a drill like this. So if you wanted to drill something, see we have a drill bit in here. This little item here moves that thing up and down as I crank it. So now I want to get it down to my drill piece. So I'll crank it till it gets down there close. Now it's on pretty snug. I flip this little lever over here and then begin to crank. It'll crank, and as it cranks, it moves one gear at a time. So I can sit here and crank this thing. Might take a minute or two, but in a minute or two I'll be completely through this piece of steel and drill a hole. So if you're lucky and you have a shop like that, that's how they would drill through iron. We use this. This is constantly used throughout the day. As you can tell, these little metal shavings. Somebody was drilling something. If you didn't have a drill like this, you could accomplish the same thing with punches. So you take this piece of iron and you put it in your forge, and you get it red hot. And then while it's red hot, you take it off of your, take it out of your forge and use a small punch for whatever size hole you wanted to punch. Get that on your anvil while it's red hot. Put your punch on there and just punch a perfect hole right through there. Nice thing about punching through the iron is I can make that hole round. I can make that hole square. I can make that hole triangular. I can make it any shape I want.
Whatever the shape the punch was, yeah.
Yeah, whatever the shape of the punch is, which was very convenient, because if I needed a square hole to put this on some kind of cog or some kind of device that needed a square hole to hold it, you can pull that off with your punches. So we got our wall of tongs. So these are all used by different blacksmiths. These are ones that we use very commonly throughout the day or throughout the week. All this stuff, a lot of people with non-practiced eyes may not know what a lot of this stuff is, but this whole thing is filled with tools that we can use on the top of our anvil. So it multiplies the top of our anvil. Say for instance, I needed to cut something, a big old hunk of steel. I could take this, which is this is a blacksmith in the shop, forged this out of a piece of iron, scrap, high carbon iron he got from somewhere, put a edge on it like an axe, and then this would go into your anvil. Show you this here.
Does it look like a wedge almost?
Yeah. So see this square hole?
Yeah.
So we refer to that as a hardy hole. So we could put all kinds of tools on there. Now I can get a red hot piece of iron out of my forge, and while it's glowing red or orange hot, I can put that on that sharp point, hit it with my hammer, and cut right through that piece of steel. So we do that when we make tools, when we make punches or any kind of cutting. So that's a small example, but if I had a bigger anvil and a bigger piece and a bigger hammer, I could accomplish that with any size piece of iron or any size piece of steel. I could pull that same project off.
What's the biggest anvil you've ever seen, actually?
The biggest one I've seen is a 500-pound anvil. So this one here is probably about 150, 160. I've never actually weighed it. This one here looks like it's a couple hundred pounds, so I'm just guessing, maybe 220. The largest one, probably most common ones that would be in a general purpose blacksmith shop, would be about 150 pounds. And a guy rolled in with his truck one day, and he was happy he just bought an anvil, and it was a 500-pound anvil. So it was huge. It was humongous. And another tool. So we got the forge, we got the blower, we got the anvil, we got the post vices, and the drills. And with that stuff, you could get a lot of work done. Another tool that is kind of the Mr. Humble tool would be this tank right here. So that's just, you'd have to have a tub of water, and that does all your quenching activities. So I'm making a how that comes in handy, for instance, is I made a punch, an awl. I'm gonna put an antler head handle on it. And so I took a piece of spring, scrap spring out of a garage door because I knew that would be high carbon, shaped it into a punch, an awl, and then I needed to get it tempered. So I get it into my forge right here, get it red hot, I use this little thing here, just a simple little magnet. So you get your iron in there. Okay, what in the heck would you use a magnet for? You get your iron in there red hot, a magnet will stick to it. When it hits that temperature where a magnet stops sticking to it, so I'd hang it up here and I'd put this metal right here, and if that magnet wouldn't swing over and stick to it, I knew I was just at the point to quench it. If you quench it too hot, the granular structure in the steel is too grainy, and it'll be real brittle, it'll break. So I quenched it in my fire. That made that piece of iron very hard and very brittle. So now I want to soften it a little bit so it won't snap like a piece of chalk, piece of peanut brittle. So I shined it up, I put the end of it in my fire right here, and I just watched as the colors began to migrate up that steel, and I knew when the color turned bronze on the last inch and a half, that would be hard enough to stay sharp and soft enough not to snap. At that point, I dropped it back into my tank, and I quenched it right there. So that assures me of a good hard tip, not too brittle and not too soft. So all that's pulled off with just these simple tools. So whether it's blade making or knife making or whatever you needed to do, you could all do it in a general purpose shop like this.
I see a lot of like shows and stuff. They talk about how the key to good metal is a hot and cold process. Heat it up and then cool it down real fast.
That's right. And different metals, you do it different ways. Some of them call for water quenching. Some metals call for oil quenching. Because some metals do well if they're quenched in water. Because in cold water they'll get cold the quickest. And some metals can handle that. Other metals you don't want to cool them down that quickly, so you'll put them in oil. So it cools down a little bit slower, but the iron reacts better to it. So it all depends on what kind of iron you're working with. Generally a water works good for your basic steels, high carbon steels, 1095s, 1075s, 1085s. Your tool steels, 01 tool steel, different steels like that, they ask you to quench it. The instructions are to quench it in oil, preheated to 130 degrees. And so they have but back in the day, in the old days, you pretty much knew it by working with different stuff. And if you had a source of iron or steel that you didn't know what it was, you would experiment with little pieces of it until you knew what was the best temperature to quench it and what was the best temperature to temper it and harden it. And that just came from experience of working in your shop. So now, of course, these days we just download the app on our phone and we say, I got X kind of steel, how do I heat treat it? And it'll give you precise instructions. Back in the day, that just came by doing old
Experience.
Experience, exactly.
Cool.
And a lot of shops, this is the basic heart of a shop. And what the shop did, like this shop here, because it's on Main Street, would have been on Main Street in the old town. There was 300 buildings up and down the street of Kelowna, and people would go to this blacksmith to get general purpose blacksmithing, kind of like a general hardware store. Prior to the hardware stores, a lot of blacksmith shops with the same basic stuff, they would set them up out in front of their old mines because he was the mechanic. So he repaired anything that had to do with what was going on with the mine, any kind of equipment, any kind of tools, needed fashioned, needed made. He was the mine's mechanic. So it would depend on where you went and what you did would determine what kind of work you did.
Imagine back in those days, this town was really banged with gold. They stayed pretty busy.
Yeah, there was blacksmiths here when it was first discovered. There was a Mormon brigade that came up that stopped at Sutter's Fort down in Sacramento.
Yeah.
And Sutter hired Marshall to come up and build a sawmill to get lumber. And there was also Mormons that had come up and were stopped at the fort, and he hired them to come up and work with Marshall in the gold fields. So they were skilled laborers. So they brought their blacksmith shop, their anvil, and everything they needed, and we're here in the gold field because you're going to build a mill.